So I wanted to talk about this math problem about bridges. It's more of a puzzle than like a serious math problem, but this is actually a very interesting problem. So a couple of hundred years ago, there was this town in Europe where it had a huge river, and then there was an island. There were two islands actually. In the river, and then seven bridges. The first bridge here, the second bridge is here, the third, the fourth, the fifth, sixth, and oops, never mind. So this island only gets one on each side. So these are seven. 1, 2, 3, 4, 5, 6, 7. So this is the river, and then this green part is an island, and then these are just lands. And then there was this guy who was living in a house here, and then over the weekend he's bored. There's really not much to do a couple hundred years ago over the weekend. So he decided to take a walk. And he liked the view of the river, I guess, or whatever. So he decided to walk around and then just, go across bridges. And he had this one rule that he didn't want to go through the same bridge twice in the same day or in one walk. So he might go through these two bridges and just come back. Or maybe sometimes he might go through those two islands and come back. Since he doesn't enjoy, the same scenery many times, going through the second bridge halfway through and coming back, something like this is not really his favorite. What he's primarily interested is really a path where he gets to walk through a new bridge, different bridges every time. And then he realized that there doesn't really seem to be a way to go through all the bridges and come back. Like, no matter where he starts, like which bridge he starts with, it seems impossible. Like, if you get here, like, he can't come back anymore because he doesn't want to take the same bridge twice. And so the question is it possible to start from this, his place, and walk around and go through all the bridges and then come back home? There are actually a few variations to this problem, but I'll just be discussing this one. And then it doesn't seem possible, but at the same time, it's not really clear as to why it's not possible. Like, it's really hard to explain. And it's actually a really concise solution to this. This actually became a famous problem back then, and then this famous mathematician called Euler gave a proof as to why this is impossible. And the solution is actually relatively simple. So notice that there are 3 bridges that he can take at first. And those 3 bridges are the only way to get back home. And then these are the only options that he has when he leaves home. And what happens is that first he leaves home and he takes the first bridge, right? And then he will be once he take a bridge, once he takes the first bridge, I just drew this line. After the first passing, he will be on this side of this line. So it doesn't matter which bridge he takes for the first one, but after he crosses the first bridge, he will be on the northern side, the upper side of this yellow line. And then if there was a way to go through all the bridges and then come back home, since there are 3 bridges that I marked red, he will eventually take the second one, right? And then when he takes the second one, he will come back to this side of the yellow line, below the yellow line. And then since there are 3 bridges, and then since we're assuming that, he found a way to go through all the bridges, he will go through the 3rd bridge. And it doesn't matter which one it is, but he will definitely be above this yellow line. But if he was on the yellow line, he wouldn't be able to get home without crossing one of these bridges, because this house is on the southern side of this line. And if you really think about it, every time so in order for this to be possible, because every time he leaves home and they go somewhere and comes back, he needs 2 bridges, 1 and 2. However, there are only 3 bridges. So if there were 4 bridges, maybe it could have been possible. But since there are only 3, it's just not possible. He will always end up on the other side.